Hi dear students, I hope you have watched all the PYQ sessions from organic first chapter, haloalkanes and haloarenes. Now we are moving on to the second chapter, alcohols, phenols and ethers. We are going to see some PYQs asked from the second chapter of organic in the sessions coming up. Hi, I'm Prasanna Saji. Welcome to my platform, ChemSmart. Let's see what the questions are. Question number 1. Aspirin is obtained by the acetylation of which of the following compounds? You have studied in esterification area of alcohols and phenols that salicylic acid is 2-hydroxybenzoic acid. Salicylic acid is a common name. When you acetylate it using acetic anhydride, you will get aspirin. So the answer here is salicylic acid, which undergoes esterification to form aspirin. So the answer is salicylic acid. And that same question is repeated in 2022 also. When we reach there, I'll show you even the reaction. What happens when phenol reacts with concentrated nitric acid? What will happen if phenol reacts with concentrated nitric acid? You know, when phenol reacts with concentrated nitric acid, what will happen? You know, the OH group in phenol is electron releasing and hence ortho-para-directing. So you will get ortho and para product individually if it is dilute HNO3. But if it is concentrated HNO3, all the three positions, that is both the ortho positions and the para position, will get simultaneously attacked and you will get the tri-substituted product. So the product formed here will be 2,4,6-trinitrophenol. This is 2,4,6-trinitrophenol. It's better to write its IUPAC name and common name as well. So its common name is picric acid. It is also a common question given in papers for IUPAC nomenclature. So 2,4,6-trinitrophenol or picric acid, that is the product formed when phenol reacts with concentrated HNO3. Clear? Practice, as I always tell you. Then the next one is when phenol reacts with chloroform in the presence of aqueous NaOH followed by acidification. You are asked to write the reactions only. That means it is a Remer-Thiemann reaction, if you remember. Phenol reacting with chloroform in the presence of aqueous NaOH, you will get an intermediate first, that is substituted benzyl chloride, which undergoes hydrolysis to form salicylaldehyde, that is 2-hydroxybenzaldehyde or 2-hydroxybenzene carbaldehyde. So we are going to see what is that reaction. There what happens is you take phenol, make it react with chloroform and aqueous NaOH. Then you will get an intermediate which is substituted benzyl chloride. Please refer to the textbook and take the detailed reaction from there. We are just discussing it quickly. This is substituted benzyl chloride, intermediate. And then that on further treatment with NaOH, you will get another compound, that is you will be getting ONA and CHO, which on further acidification, you will get OHCHO, which is the salicylaldehyde. Clear? So this is basically Remer-Thiemann reaction. Practice the Remer-Thiemann reaction equation very well. All the name reactions, their explanations, as well as the complete equation you have to write and practice if you want to score in organic chemistry. Clear? Even in conversion area, complete the following everywhere. The paper setters, they make use of these name reaction concepts very commonly. So make sure to prepare. Then the next question, why is paranitrophenol more acidic than phenol? So you have to compare the acidic nature of paranitrophenol and phenol. You know, something is acidic if it can give out H plus very easily. That is, phenol can behave as an acid through the formation of phenoxide ion and H plus. And it's a weak acid because the dissociation is not that great. Okay, that means it is a slow dissociation, dissociating to a lesser extent. So phenol is acidic, but it is a weak acid. Now, if you take paranitrophenol, what will happen in paranitrophenol? This is paranitrophenol. Let's see what will happen if it dissociates. You have studied that the nitro group is electron withdrawing, right? So the nitro group is electron withdrawing. It will withdraw electrons away from the ring. When it is withdrawing electrons, that impact will come here also. Here also. That means the OH bond, from the OH bond area, electrons are being withdrawn. When electrons are withdrawn, the bond will become weaker and more polar. It can easily break compared to the OH bond in the normal phenol, which is not substituted. So this bond will be more polar than this bond, or this bond can get easily cleaved. It is weaker, easily cleaved to give out H plus. That is, its conjugate base is this one, paranitrophenol ion plus H plus. So we can say this dissociation is more feasible compared to this one because of the weak or more polar nature of the OH bond. So easier release of H plus means it is a stronger acid than the other one. So paranitrophenol is more acidic than phenol. Basic reason, the electron withdrawing nature of the NO2 group, and it makes the OH bond more polar and weaker, and easy dissociation or more dissociation compared to the unsubstituted phenol. And or in other words, we can say this phenoxide ion is more stable than this phenoxide ion, right? Because of the presence of electron withdrawing group, the negative charge is getting delocalized. Understand? So it will become more stable. That means this is more acidic than phenol. Clear? Practice. Now, the next question. Why does the reaction of sodium methoxide with the tertiary butyl bromide give 2-methylpropene and not CS3-tri-C or CS3, means not the either? What is the reason? When an alkyl halide reacts with alkoxide to form an ether, that is Williamson synthesis of ether, which follows SN2 mechanism, right? So, in SN2 mechanism, the order of reactivity is primary more than secondary more than tertiary, because it depends on steric hindrance, right? So here the alkyl halide use this tertiary. So SN2 mechanism becomes difficult because steric hindrance is more. So automatically it has a tendency to undergo elimination rather than substitution, because this sodium methoxide, the methoxide ion which is produced from sodium methoxide, it not only acts as a nucleophile, it can act as a base also. So it can induce elimination here, and it is through the carbocation formation, you know that. So what happens is this can undergo elimination, means when the alkyl halide is tertiary, the alkyl halide use this tertiary, it will undergo elimination in comparison to substitution. So what happens here is, here, if you use a tertiary alkyl halide, that is here, it is tertiary butyl bromide, which is given in the question, or 2-bromo-2-methylpropane, when it reacts with sodium methoxide, it is actually not the substitution what is happening. What is the substitution? This Br can go with Na and OCS3 will get substituted here. If that happens, it will be either, but that doesn't happen. It is undergoing elimination. And how that elimination happens? Look here. I'm going to show you what is the elimination. This is alpha carbon. Halogen connected carbon is alpha. Functional group connected carbon is alpha. And these are all beta, right? So it can undergo beta elimination. From any one of all the 3 CS3s are equivalent with respect to the C. So from any one beta carbon, one hydrogen can get eliminated, beta elimination. As per what I have shown here, the double bond will be, because I have shown it like this, double bond will be between this alpha and beta carbon. So the product formed here will be CS3C, double bond CS2, CS3. And now, what are the byproducts? That removed HBr will combine with the HBr, which we are removing from here, will combine with this one to form NABr and methanol. So those are the byproducts. And make sure to practice this area well from the chapter, because it is also commonly asked in recent board papers. That is, when the alkyl halide use this tertiary, what is happening? Questions related to that. Okay? Make sure to practice. This is very, very important. So, why does the reaction of sodium methoxide with tertiary butyl bromide give 2-methylpropene and not the ether? Reason, it undergoes elimination, not substitution. Its details you take from the textbook and learn it as such. Now, the next question. The product formed in the reaction. You know, here there is an ester linkage, isn't it? Here there is an ester linkage, and here it is a ketonic group, right? Now, what will happen? We are using a reducing agent, sodium borohydride. It's a reducing agent. So it cannot reduce the ester part. So it will preferentially reduce the ketonic part. So the ketonic part will get reduced to secondary alcoholic group. So this will get retained, and C double bond O changes into CHOH. So this will be the answer for this question. Clear, everyone? Yeah. Now, the next question. Which of the following acids react with acetic anhydride to form a compound aspirin? The same concept we have used in the question 1 of this same session. I have selected this question again in the same session to make you understand that this concept is repeatedly asked. The first question was from 2023. This is from 2022. That means this is repeatedly asked. Prepare well. And here I am just going to show you how salicylic acid is reacting with acetic anhydride to form aspirin, just to show you what that reaction is. Look here. What is salicylic acid? Salicylic acid is, you know, this is benzoic acid. Ortho position, you put the alcoholic group. So this is 2-hydroxybenzoic acid or orthohydroxybenzoic acid, that is salicylic acid. Let it react with acetic anhydride. So what is acetic anhydride? I am just detailing its structure. CS3CO or CO CS3. In the presence of H+. What will happen? What is the reaction happening here? Look, H of the OH goes with this much. That means in the place of H, the acetyl group is getting inserted, getting substituted. That is why we call it as acetylation of salicylic acid. Clear? So what will be the product now? I'll write the product here. So it will be, nothing happened here. We retained it. Now O, then to that O, the acetyl group is getting connected. So, and plus what is the byproduct? CS3COOH. CH3COOH. That is the byproduct. And this is your aspirin. And what is the IUPAC name of aspirin? It is asked in some of the previous papers, though not in recent papers. You should know what is the IUPAC name. You know this much is benzoic acid. So 1, 2. Second position, you know this is acetyl group. Acetyl plus oxine is acetoxy. So it is called 2-acetoxybenzoic acid. 2-acetoxybenzoic acid. That's the IUPAC name of aspirin. And this is the concept of aspirin formation by acetylation of salicylic acid. Practice very well, including the equation. Clear? That's all for today in this session. I hope all these questions, concepts are crystal clear to you, as I always tell you. make sure to like, share, and subscribe to my channel. I see that, you are enjoying the sessions from the comments what I get. And please make sure to like, share, and subscribe also. And see you inside for the next session. Till then, bye. Make sure to watch all the previous videos uploaded in my channel from all the other areas what we have discussed. It will help you a lot. No doubt about it. Okay? See you inside for the next session.